Welcome in this tutorial on Python Pandas tutorial for beginners. We will walk through the process installing pandas and exploring a dataset using pandas. Let's get started. In this video, we're gonna contribute the contents as you seen in your screen. First, setting up the data science environment. Second, data integration. Third, exploratory data analysis. Fourth, data cleaning and preprocessing. Fifth, feature engineering. Sixth, data visualization for insights. Seventh, data manipulation for modeling. Eighth, advanced pandas techniques. And ninth, integration with machine learning. Now, let's start with our contents one by one. But firstly, let's get started with setting up our data science environment. So what we do when we are setting up our environment, we have to create a virtual environment, and it is a good practice to create a virtual environment for your data science project. This isolates your project dependencies on the system-wide ranges. If you haven't installed the Python yet, install now. You can install your Python by using pip install pandas, or if this is not working in your environment, you can even try pip install pandas. Either both of them will not work. You go on Google and search for it. There is some environment issue in your network. You can also install matplotlib for our data visualization with pip install matplotlib. Now, as we have set our environment for data science, now we can eager learn to what do next. Let's intro to our dataset. Here we are using Bangalore house price dataset as you are seen in the heading. So when we look into the dataset, we see something like this. The significance of the dataset are: the Bangalore real estate market is one of the fastest growing in India, and this dataset can provide valuable insights for property buyers, sellers, and investors. Analyzing this data can help answer questions like property prices trends, locations, preferences, and factors affecting the property prices. In this dataset, we have several columns as you seen in the figure, like area type, availability, location, size, society, total square feet, bath, balcony, and price. Here bath represents the bathroom, as we can understand it easily. So now that we have set our environment and also introduced the Bangalore house price dataset, it's time to load our dataset and start our data science journey initiated. So how to install our dataset? Before installing our particular dataset of Bangalore house, let's first go through the pandas library initiations. So in this data ingestion, we gonna learn about how the pandas work to make our data frame. First, loading the pandas library, which we have already done in our first section. Second, making the data frame using pandas. So firstly, we import the pandas. After importing the pandas, import pandas as PD. Normally in so many big data sets, we are using the pandas as a short form in PD, as it took so many alphabets while using pandas and creating a long form of data sets. So here I have made a small data set as data with 3 columns: name, age, and marks, with 3 rows A, B, C, where age is 34, 23, 14 and marks is 56, 62, and 89. In this data set, we use pandas to create a data frame as pd.dataframe. Here the data frame field used to make the data frame easily of any kind of data set. So we get to see our data frame as df here. Now, if you want to convert our df data frame into the CSV file, we have a single line of code as shown here. In 6 line, I have used to convert the data frame into our CSV file by using 2 CSV field. This 2 CSV function is easily convert the data frame into a CSV file or either a different files which we have in our registered library. Now that we have seen the basic pandas function, Now it's time to load our real data set. To load our real data set, we just have to follow the syntax as shown in the above. df1 is equal to pandas pd.readcsv. Here the readcsv file does the read the path of the data or name of the data with the file extension, and just load the data frame in front of our Jupyter notebook cell. As shown in the figure, while I am using pandas dataset as a path of data, you can see pd.readcsv in brackets. I have used r in front of the brackets. This r means to be read. So it reads the entire path of the data, which is my local drive path. You can also download the data from the given description link, and from your local drive you can choose the path of the data and read your CSV file as the similar syntax to be followed. We can already see in our data set, as we have so many columns as area type, availability, location, size, society, total square feet, bath, balcony, and price. Now, as I have seen the data already, let's continue to see the head, tail, and the features of our data. So let's quickly inspect our first few rows of the data set. So how we inspect that? Definitely with df.head. This df.head helps us to display the first 5 rows of the data set. Similarly, df.tail helps us to explore the last 5 rows of the data set. We have few different functions as well, as df.sample. df.sample what does exactly? It pick out the random numbers however we want to see. Like here, just I have used df1.sample. I get to see only a single random data set. Every time when you use to run this code or this piece of code, you will get the different results, as the sample may be a random number from the entire data set. Similarly, when I get to see 3, we get to see 3 different random rows from the whole data set. It can be either same or changed in the different ways of cell reading process. After df samples, we have few different features as well, as df columns and df shape. What these two features do? So df.columns totally initiates the column names in front of us, so we can get to see the entire column names together. As you can see, here are the indexes, and in every brackets, in every columns, there are the column names which we have which we already seen in our data set in previous slides. And what the df.shape do? df.shape gives us the rows into columns in a bracket formation. Like if we run this, we get to see that in this data set of Bangalore house, we have total 13,320 rows with 9 columns. Now we are here to see isNull function. How the isNull function works? If I just run isNull function for our data frame df, what I get to see? I get to see a long ways of true and false values put in every row and column, as you can see in the figure. But for a bigger data set, is it possible to use isNull function and count the every true and false by your own? Definitely not. This is not a proper function which you can use to just count your thing. So how we can count our isNull? Simple. We have a different function. With isNull, now we're gonna use .sum. What .sum will do? The sum will do the total counting of true and false, and which help us to know how many columns and rows are missing from this particular data set. These are the numbers which are isNull false. IsNull true, sorry. IsNull true means we have that number of blank functions in our data set. So apart from df.isNull.sum function, let's see how we can sort the rows from the shape column. As the shape is the form in the list, so we just have to call the first cell of the shape, which can be easily called by shape 0. So if we use df.shape0, we get to see the rows of total data. The total data is our data frame here. So after that, let's do a task in our particular data set. So here I am taking a task to calculate the percentage of missing values in society column. So in society column, first we check using isNull.sum function as we see earlier. So we get to see the null values as 5501. It means in total rows of 13,320, we have 5,501 column as a null function, as a null values. So to put out the percentage of the null value, we simply divide it with the total data into multiply it 100. We get to see as 41.29% are missing out here. We simply use this function and get to see our values as output. Let's continue. Now we will start the second part of our content as exploratory data analysis. Before starting exploratory data analysis, I would like to inform you about some data explorations. With our data loaded, we can begin our exploratory data analysis as well as our analysis with visualizations. So, we can perform various operations on data sets such as checking for the missing values as we have already seen, and summarizing the statistics, visualizing the distributions of the data, etc. Now that we have to perform the exploratory data analysis to gain the insights from the data, let's start from the summary statistics with describe. Pandas describe method provides the summary statistics for numerical columns. Let's use to get the overview of our dataset. When we use the df.describe, we get to see our summary statistics like this, where we get to see few columns and few rows as count, mean, standard deviation, minimum, maximum, and the percentile values from 25 to 75. This will display the statistics like different numerical columns as well as also help us to understand the dataset very easily and very sufficiently. After that, we are going to visualize our distributions using histogram. Histograms are very useful for visualizing the distributions of numerical data. Let's create a histogram for area column to see the distribution of the house size. When we use the distribution of the house size in Bengaluru dataset using the area type column, as we have plot the figure size of 10:6 with the title of distribution of house size in Bengaluru as shown in the output with the X label, where it is labeled as X, area in square feet, and Y label as frequency with a sky blue color. We can choose our color as well. So we get to see our histogram like this. If you haven't even installed matplotlib library, you just have to pip install matplotlib and import using import matplotlib.pyplot as PLT. PLT is used in very wide way. We can either use the different names as we want, but PLT is used in a very wide way, so it's better to use PLT if we want to easily understand our all data. Let's continue with a different visualization distribution with boxplot. Boxplot provides a summary of the distribution including outliers as well. Let's create a boxplot for price column. So in this price column, we get to see that the boxplot can help to identify the outliers and the overall distributions of the price variable. You can see this value is very outside of the box plot. So this particular plot is considered to be outlier if it is not significant or not in useful way. You can check out the different videos to check more about box plot and outliers. So in this section, we have performed the EDA by calculating the summary statistics, handling the missing values, and visualizing the data distribution using the histogram and box plots. EDA helps us to understand the dataset better, identify potential issues, and also to make informed decisions during our data analysis. Now, let's continue with our next topic, data cleaning and preprocessing. In data cleaning is definitely a crucial step before modeling. Let's continue with the task to get the data info, and let's continue with filling our missing values as well. So when we run data info, what we get the total informations of the data in different formats. Here you get to see the column names, non-null counts. Here the society has 5501 null function, which is 41.29 as we seen earlier. So we only get to see 7819 not null count here. And also we get to see the data type, D type, as written in column in the info section. And similarly, when we use df.isNull.sum function, we get to see the direct null values available in the particular columns. So these are two types where we get to see the information as df.info and null values as df.isNull.sum. Now we have to initially check what kind of data values we have while we are filling with missing values. Initial checking have some basic functions and basic process. Like first we have to check the data type. As the data is from the object data type, we cannot go for mean or median. We can only have a single choice of mode to use by filling the missing values in society column. So for that, we just have to check out the mode of the society column, which is GRRVAGR as written over here, and also signified it with 0. So while filling the missing values, we are going to use that mode column with that 0 initialization, so that in most of the filling missing values, we get to see GRVAGR while ensuring that we have not null values another. Again, after df.fillNA function, so while we are filling our different missing values, we can check our knowledge to understand the statistical method for the imputations. Here we are using the fillNA functions with the mode of society as a value 0, as the given value of this particular data type is 0 here. And then we again check the isNull.sum function. We get to see that our society is now haven't have any null values. So we are done with our filling null values. You can also try the same variety and same thing with location, size, bath and balcony as well to practice out yourself. Now here we are coming for the encoding categorical variables. So the categorical variables need to be encoded for machine learning models. We can use one-hot encoding or label encoding depending upon our variables. Here I am using the getDummy function for the encoding. So the getDummy function, what exactly does? It creates the so many dummy variables and which help us to encode in a proper manner. You can see for locations I am using that getDummy function. You can follow the same for steps for the other columns which you have as a dummy or encoding techniques as well. In this section, we get to see a lot about our converting data types, encoding sections, filling missing values. Now we are going forward for feature engineering. Feature engineering involves creating new features based on the existing one. So here I am taking a task as to find out a house where bath is minimum 2 and the price would be less than $2,000. So here we need to compare so many columns together to get this information in a row or in a starting head of 5 rows. So I am using here bath, where less than equal to 2, which means minimum is 2 and we have up to maximum 3, 4, 5, whatever we have in our data set. And here AND function equally creates the comparison between first and second thing. For price, I am using the price would be less than 2000, and here we just need to mention the columns which we need to see in our output. I want to see the location and area type, so I just mention the location column and area type. I want to see the starting first 10 rows of this particular feature, so I am using dot head 10. You can either use 5 or either put it on default, which is 5 first rows, to see your output. I'm getting this output as the best is on Electronic City Phase 2, similar in second in Chikka Tirupati. You can check out similarly with your different feature engineering methods. Now, here I am using different fields to extract the meaningful attributes. We have a column availability where we have a ready to move section, as well as January, February, different types of month as well, to mention that what is the availability of that particular area or that particular flat in Bengaluru. So I am filtering out with January string content function. So the string content function, what exactly do? It compares the particular column having your mentioned string, and if it has, then it easily gives you the output as I get. So rows available in particular January as shown in the figure which we gave as an output. After that, let's go into the different topic of binning continuous variable, where we get to see the binning in the particularly balcony column to size categorize. Here we are having a different values in our balcony column as 0, 1, 2, none. So I am using it to label as a different without balcony 1, 2 and 3. So what we get when you use binning as pd.cut, beans is equal to beans, which we already mentioned, and labels we convert with beans. So it categorizes the property size and the balcony as mentioned based on its values as 1, 2, 3. And we get the output like this. All the beans converted 1, 2, 3 into the particular 1, 2, 3 and without balcony values. So in this section, we have performed the feature engineering by creating a new features based on the existing ones and extracting the meaningful attributes from the different fields, and also see the binning continuous variables. Now, these engineered features can enhance the quality and richness of the dataset for our further analysis and modeling. Let's jump into a different topic of our content, data visualization for insights. And let's first learn about the correlation heat maps. So the correlation heat map helps to identify the relationship between the numerical variables. For that, we firstly need to import our Seaborn library as SNS and matplotlib library as PLT. We again use the ratio of 12:8. Matrices main function which we use here is df.corr core, which identifies correlation heat maps. So a correlation heat maps displays the strength and directions of the relationship between the numerical variables using the color intensity. As you can see here, the color intensity red, blue, light blue. The correlation here uses the different columns and rows to identify the relationship between the numerical variables using the color intensity. As you can see here, the colors of red, blue, light blue, etc. Let's continue with our scatter plot, which helps to visualize the relationship between the two numerical variables again. Here I am using the scatter plot of area using the total square feet column versus price of the particular rows, we get to see that we had a wide range in 0 to 500 lakh, where after that we have a limited range. So this is how the scatter plot look, and this is what are the columns we use to complete our scatter plot. This scatter plot visualizes the relationship between the area with the price to identify the patterns and trends, which help us to easily analyze the dataset. Now let's use the bar plot for categorical feature distribution. Bar plots are useful for visualizing the distribution of categorical features. As you can see, a bar plot displays the distributions of property sizes as here I am using the balcony column. So it uses the balcony column as without balcony, 1, 2 or 3 balcony as a distribution of balcony into the sizes and sections. So in this section, we perform data visualization to gain insights from the Bengaluru dataset, and we use the correlation heat map to identify the relationship between numerical variables, scatter plots for the bivariate analysis to explore area and price relationship, as well as the bar plot to visualize the distribution of the size categories in the balcony to see the categorical features. These visualizations help us to understand the data and make us inform the decisions during the analysis. Let's continue with our next topic, data manipulations for the modeling. So in this data manipulation, we are ready to prepare our dataset for modeling while involve splitting, grouping and reshaping. So let's do the splitting of the dataset into training and testing. To split our dataset into training and testing for model evaluation, we just have to use for sklearn model selection, because all the test and split is on sklearn library under model selection module, and we use the feature and target. The features are in x-axis and the target variable in y-axis. As we have a target variable, it's easy to identify that here we are going to use supervised machine learning, and this is the format which we use to split our dataset. In every dataset of features and target variable, we have two parts as training and testing. We have two test size as well when we create our splitting, as 80-20 ratio as a in 70-30 ratio. When we have a big data set, we used to have 30-20 ratio, 30-70 ratio, but as this data set is not that much big to use that ratio, we are going to use our test size as 0.2, which means we are here using 20% as a test size and 80% as a train size. And what you might be considering about what that random state mean by. So this random state is meant by shuffling. Here the data set is used to shuffle that many times which we return over there in random state. So as I have written 42 in random state value, the whole data set will shuffle 42 times when we are using this data to train our model. So let's see the grouping and aggregating data for insights. We can even group and aggregate data to drive our insights. As you can see here I am using the price as a size category and group by its average price. We get to see the mean of balcony with 1, 2 and 3 in different prices range as 90, 109 and 150. Whereas the 3 gives us NAN, which means there is no mean values, which might be higher than 150 as well. Let's continue with our next topic, and while we are using resampling with melt function. Here I am using the melt function where I am using the size categorized, which we already use while sampling the balcony, and value for prices, and a value name as a price value. We get to see this kind of output. In reshaping, we used to see the reshaping of the data with different functions, either with melt or either with plot. Let's see with plot as well. Here I am using table. Table is used to indexify and the columns and the values together. As here the index is size category, where it is uses the location. So the size category is divided for location, with or without balcony price, and with one or two balcony prices, where the aggregate function we use to find the mean of the values, as we have to resample the data. Now let's continue with our different contents, which is advanced pandas techniques. Here we are using handling time series with the rolling statistics. So what the rolling statistics do? As we in the earlier section we perform the data manipulation for the modeling, we split the data into training and testing for the model evaluation, group and aggregate the data to gain the insights, reshape the data using the melt and parrot table, and this manipulation help us to prepare the data for the modeling and in-depth analysis. So in this advanced Python techniques, we are going to see a bit forward in the same pandas techniques. Pandas offers the advanced technique for the specific scenarios. The specific scenarios, like for time series, we can use the resampling and the rolling statistics. So calculating the rolling statistics like rolling mean and rolling standard deviation, as you can see here, rolling mean and rolling standard deviation, it can help to identify the trends as well as the fluctuations. So I am using here a random value 30 for the windows and using the standard deviation and mean, and get to see the standard deviation values. We get to see there are so many NaN as well as the wonderful values from 94 to 126. While we roll the statistics for the standard deviation, we similarly see the output by change the rolling standard deviation to rolling mean to see the rolling mean output. Let's use the query for more readable data filtering. The query method allows for more readable data filtering, as to filter the house with 3 bedrooms or with more than one balcony where the price can be less than $10,000 or $100,000. I'm using the same filter here using the query. So using query makes complex data filter conditions more readable as well as more concise. As I am here filtering the data using df.query, where I use more than one bathroom, or you can either use 3 bathroom, price less than 1,000, 1 crore, so we can do it as $100. As for Bangalore, we are using the price in dollars, and we get to see that many columns while filter this particular query. Let's optimize the data storage with categorical types as well. So use categorical type to optimize the data storage. We are converting the size category into the categorical type, reduce the memory uses, as well as also speeds up the operation on this categorical columns. So while we use it, we get to see the availability with the balcony mentioned sizes, as the size category is based on the balcony column. So in this particular section, we explore the advanced pandas technique. We learn how to handle the time series with rolling statistics, also use the query method to read the more readable data filtering, and optimize the data storage with the categorical types. These techniques are very valuable for the specific scenarios and also help us to enhance the efficiency of the data analysis. Let's continue with our next content as integration with machine learning. So Pandas plays a crucial role in machine learning workflow. It helps in data loading, pre-processing, and feature engineering, making the data more suitable for the machine learning models. So in this section, we are preparing data with sklearn, which shows us how pandas fit into the ML workflow. So for fitting it, we get to see the features which we want to sort out. You can either choose whatever your columns that is intended to see in your output, with X column as a features and Y column with a target value which is price definitely. Now we are preparing the data model with the sklearn using the sklearn.model selection, as we already seen during test and train split. While we implode the train test split and split the dataset using the same random stat 42 and the test size of 20% into 80% of ratio as 0.2. So the scikit-learn, or I can say sklearn, is a popular library for machine learning in Python. It seamlessly integrates the pandas for data preprocessing and model building. So now we have integrated already. The data is now splitted into the training and testing set for our model evaluation already. Let's give a brief intro to the feeding data from pandas to a basic ML model. Let's create a simple linear regression using the scikit-learn to predict the house prices. So for that, we again use the sklearn library, particular linear model module, where we import the linear regression. As I can already said earlier, that as we have a target output, we are going to use the supervised machine learning. In supervised machine learning, we are here going to use the linear regression as one of our supervised machine learning model. So for creating a model, we can use the linear regression as a function here and train our model using xtrain and ytrain, as these two are the train values to fit our model. Then we have to make our predictions on the test data. So we can just predict our x test and put it in our y predict column. We can also evaluate our performance using the matrices like mean squared error, t-test, accuracy, precision, etc. And we can either print it on the same basis. So in this brief example, we used to see the scikit-learn to create a linear regression model. We also create a linear regression model. We have trained the model on the training data, made the predictions on the test data, evaluate its performance to see the used mean squared errors. So let's see the summary. In the summary, we can get to see that we firstly initiate the data, check out the data to understand it in a better way, then do the data initiations. In data initiations, we get to see the head, tail, info, sample of the data. Then we put out our data into exploratory data analysis, EDA. Here we perform the basic exploratory data analysis in our particular data set using the task functions and the task. After that, we get to see the data cleaning and pre-processing. In data cleaning and pre-processing, we do the basic fill NA values and clear it with the missing values. Then after, we go in modeling, where we get to see the advanced data types as well. And also we work on advanced pandas techniques. Then we integrate it with machine learning, where we get to see the linear regression as our model. So as pandas is an integral part of the machine learning workflow, it helps in the data pre-processing, featuring selection. Scikit-learn seamlessly integrates the pandas as well to build and evaluate our machine learning models. So in this brief introduction, we create the linear regression using the scikit-learn to predict our house prices in this integration. For that, I have divided our summary in 5 parts as a data initiation, EDA, data cleaning, modeling, and integration with data machine learning. So this is the whole summary, where we get to learn the main uses of our pandas library. If still you are eager to expand your data science skills with further and dive deeper into the advanced pandas techniques, as well as explore how the pandas seamlessly integrates with other Python data science libraries, we can recommend you to check out the Project Pro. So the Project Pro offers a wide range of the courses and projects in data science, machine learning and more. And you will also have an opportunity to work on the real life projects, real world challenges, gain hands-on experiences and learn from the experts in the particular field. Whether you are interested in pandas, scikit-learn, data science, data visualizations, or any other aspects or machine learning as well, Project Pro will help you and give you the resources for your advanced data science journey. Visit Project Pro today at www.projectpro.com to explore the exciting world of the data science. Thank you for joining us here. Best of luck in your data science endeavors. Thank you.